Hello, everyone. My name is Timothy Lee Grant, and look at the time. Look at the time. It is December 24th and almost midnight, Christmas Eve, and we're about to welcome in Christmas. And what better way to welcome Christmas than grinding Leetcode? Yes, we are gonna have fun. All right, let's go. This is a Christmas stream right here. Grind and Leetcode. All right. So, first step, randomize, pick the next closest medium. So, here we go. We are picking, which one are we picking? Well, this one's locked, so we're not doing that. Here is the closest non-lock. So, number of closest islands. All right, let's see if we can do it. Okay. Okay. So, 1,254. Number of closed islands. Given a 2D matrix, 2D grid consists of zeros, land, and 1, waters. An island is a maximum 4 directionally connected group of zeros. Okay, so 0 is the land, and the definition of an island is a maximal 4. Wait, hold on. When it says maximal, that means that if there's only one of them, that satisfies the condition. If there's only two of them, it satisfies the condition. So does that mean if there's like a big island that there's 7 connected and it's no longer an island? Is that what it's asking right here? Or what it's implying right here? Okay, so where was I? And a closed island is an island totally, all left, top, right, bottom, surrounded by ones. Okay. I'm going to have to reread this problem again, and so we're going to be looking at the examples and then rereading the problem because I'm not quite seeing exactly what we're supposed to be doing. Okay, so return the number of closed islands. Okay, so we care about these like closed, and okay, so the definition, an island is a maximal 4 directionally connected group of zeros. So do I see 1, 2, 3? So does this count as an island right there? Okay, so now closed island, this is another definition, okay? A closed island is an island totally surrounded by ones. So this, I'm guessing, is not considered a closed island because there's not a 1 here. Okay, whereas this right here is a closed island because you see it's completely surrounded by zeros. Likewise, oh, you see all of these ones, actually. Oh, wait, sorry. 0 is land. My mind is all topsy-turvy because normally they switch that. Okay, so the 1 is water. So all of this is water. All of this is land here. But does this count as an island? Because it is greater than 4. Likewise, so this would be an island because it is only 1. And by definition, it says left, top, right, bottom. So we're not counting the diagonals. So it doesn't matter that this is also land here. So up, down, left, right. So this should classify as a closed island. Okay. What about this one? This one is connected to land. So 1, 2, 3, 4, 5. Therefore, it fails the definition of an island. This one has 3, but as we just mentioned, it's not closed because this is not surrounded by 1, and this is the only other one, or only other land that I'm seeing, and it also fails the definition of closed because it's not here It's not surrounded by water here and here. Okay, so output is 2, so never mind. Somehow they got 2 in this. Islands in gray are closed. Okay. It's saying that that's an island, and this is an island. This is why we're going to have to go reread the definition and the problem statement, because from what I was thinking, that this large landmass here would not have qualified by the island definition. But we're going to keep looking at the examples and then go back up to the problem statement. Okay, cool. 10 minutes to Christmas. Okay, so explanation. Islands in gray are closed because they are completely surrounded by water. Group of ones. Okay. Sure. And I'm also noticing, yeah, it's not this one because remember I said diagonals are not counted. So it's bottom. So bottom, 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 bottom. I don't know why this one is counted, actually. This one I think should be just white, right? I don't think this one also counts because it's a diagonal. So anyways, surrounded. And then this one to kind of block off this land mass is right. This one, right? Okay, so each of them are following the definition, possibly. Islands in gray are closed because they are completely surrounded by a water, group of ones, okay? And then the other island is this one, which I said I thought is an island. So this is the one that I thought adhered to the definition because you look here, 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 and here, and it's only one land mass. Okay. So now we're looking at this. Before we look at the answer, let's try to analyze what it's going to be. So these are land, but you look here and it's not surrounded by water. This is not surrounded by water. So this entire land mass is not a closed island. Okay, so then I come here. This is water. We have land here, but we look up. It's not water. Therefore, it is invalid. So this right here, this entire landmass is not considered an island, or a closed island, sorry. Then we have water here, which, whatever. We have water here, water here. The only other land is this one. And I look up, I look to my right, I look to my left, and I look down. All water. So therefore this is definitionally considered a closed island. And so, yeah, we have one right there. Okay, and then this... Okay, I'm not looking at that. I'm not looking at that. Okay, so let's go back up to the definition and try to understand where we got off on the wrong foot with this one here. First some coffee, or not coffee, this is tea right here. All right. So, given a 2D grid, yep, consists of zeros and ones, and that's how we determine if it's water or land, yep. An island is a maximal 4-directionally connected group of zero. Okay, so it's not 4 grid units. When I heard the word maximally, like maximally connected, I was thinking that only 4 grid units could be connected for it to be defined as an island. Okay, so it's just saying is maximally four directionally connected. It's just saying that an island is a group of zeros, land, and they are connected up, down, left, right. Okay. Then it goes on to give the definition of a closed island, which is a closed island is an island totally, which means all left, top, right, bottom are surrounded by ones. Okay. So how am I going to do this? What I'm thinking is kind of like this. I am going to start and I'm going to go through each of the grid points on this 2D matrix. If it's a 1, I'm just going to ignore it. I don't care. And then right when I get to a 0, okay, now I'm going to start my depth first search. And I'm going to take this and I'm going to check, like, hey, are you fitting the definition of closed island? If yes, okay, I am going to keep traversing depth first and check all of your land masses. Okay, I'm going to check everything that is connected, and then I am going to continue to check, do you still satisfy the definition of a connected island? If all of the connected land masses satisfy the condition of connected, then I am going to say, okay, this counts as a as a closed island. This counts as a closed island. So then I'm going to return, yes, this is a closed island. And I'm going to increment the variable that I'm going to keep track of how many closed islands there are. The other thing that we need to be careful about is, okay, so we come here, great, we find this, and we say, okay, well, this does not satisfy the condition. Okay, so we still want to continue to search down because we want to add all of the connected land masses to our kind of like visited grid, because we want to know which connected land we've already been to, and we don't want to either double count an island that we've already said is a closed island, or we don't want to traverse an island that we already know is not a closed island, right? So let's say I come here, I say, oh, this is not a closed island. Okay, so then I come down here, and then I will traverse this and say, like, do my depth first search, and then I say, okay, this is a closed island. Cool, we got it. And all of these are going to be invisited. So then I'm going to come here and say, okay, well, this one is also one that we've been to, so we're not going to go and redo it. And then likewise, when we come back here, we're going to say, oh, we've already visited this one. We're not going to do a depth first search, find that it is definitionally a connected island, and then count it twice. The other thing that I'm kind of trying to figure out, oh, 2 minutes until Christmas. So the other thing that I'm trying to figure out, so I'm trying to figure out how I'm actually going to perform this depth first search, because if you think about it, so I'm here, and then I'm looking for connected. How do I determine if I'm looking in my left or my right? Like, this is the right side of the island. How do I... It doesn't matter. It doesn't matter. Because either there's three conditions. Either so I'm going to be looking left, or I'm going to be looking up, right, down, and then to my left. Okay, so either I look up and I can see land, and if it's land, I need to go and explore that land, or it's water, otherwise we're okay, we satisfy the condition, or it is out of the bounds of this map, like right here. It's out of the bounds. Therefore, it doesn't satisfy the condition. And if one time we don't satisfy the condition, the entire landmass should be said not to be part of that closed island. Okay, so let's try to start coding it and get some momentum. Oh, midnight! Merry Christmas, everyone! Yes! Okay, awesome. I love it. Visited equals set. Okay, so what are we doing? Let's see. Number of closed islands equals 0. If not grid, return 0. Rows equals length of grid. Calls equals length of grid indexed at the first. All right. Now we need a definition, a helper function, traverse, and we are going to pass in the x and y coordinates, so row and column. Very good. Then we are going to pass for now. And I said I wanted to traverse through all of the nodes here, or all of the grid points. So for I in range, rows. All right, yeah, rows. For j in range, calls. Okay, so what do we want to do? What do we want to do? We want to, if ij not in visited. So if we already have visited that specific node, we don't want to go and traverse it again, right? That's not what we want to do. So if it's not in visited, and if it is a land, so we don't want to traverse on the water, we want to traverse on the land. Okay, so and grid of I j equals to 0. Then what do? We want to traverse I and j. There we go. Else, what do we want to do? We just want to skip it. We don't want to bother with it. Okay, so now we're here. So now base case. If row is greater than or equal to rows. So now let's look at the case for here, because this is one of those base cases. So I'm going to be passing in row equals 0 and column equals 0, 1, 2, 3, 4, 5, 6, 7. Okay, so call this one equals 7 right here. And now I want to say, okay, if I am along this boundary, I know that I am not part of a connected. I'm trying to think if how exactly I want to do it. Um, but I know if I am part of this, or if I'm looking outside the bounds, I know that, hey, I'm not actually, I have hit an invalid case, and therefore I can return 0, or I can return false. So I'm here, and then I know, because I'm on the boundary, that, oh, I'm not going to be what's a definition of closed, because I look up and I look right, and I'm not closed. This one, I look right and I know that I'm not closed. So I am going to say that if I am on the anywhere on the boundary, actually, what I'm thinking is I don't want to just immediately return false, because I actually want to add this node to my uh, visited set, and then I want to continue the depth first search. So what I'm thinking about is actually I'm just going to, in my traverse function, I'm only going to return false once I hit this kind of like out of bounds case, and that's where I'm going to block. But then I'm going to keep doing the depth first search down here. So let's see, rows, when I'm at here, so or column 0, 1, 2, 3, 4. So column is equal to 4, and then calls is equal to 1, 2, 3, 4, 5. So once I get to here, I'm going to be at 5 in my rows and 5 in my, like, or sorry, I'm going to be 5 in my call and 5 in my calls, and I know that I'm out of bounds. So return false if calls is greater than or equal to calls, then we can return false. Okay, now what do I want to do? I want to check up, down, left, and right. So if grid of row column equals 1, if it's 1, I've hit water, and therefore I can just return because I am thinking recursively sometimes is very okay, so in this case I'm passing in some value, and if it is a 1, I know that it is water, and therefore it satisfies so far the condition of a closed island. So I can just say return true. Return true. Now I want to try searching left, right, up, down. So now left equals traverse, and then row, column. I'm just gonna keep doing this and change it. So left, right, up, down, so to the left I want +1 in my columns, so +1 in column. Right is -1, okay. Up is +1 in row, so actually this one is -1 in row because we want to look to that element. And then down is +1. And the other thing that we do want to do is add this current element to visited. First, okay, actually, first we want to visited.add and then row. No, actually, we don't want to do that. If row column in visited return true, okay, then add row and column to visited. So visited dot add and then row column. Okay, so what I'm doing here is I get into the case where I'm on this one right here. So I've just gone here and then I came here. I don't want to go back here, right? I want to check, like, I'm going to be here and then I am going to try to go left. I want to immediately say, hey, I've already been here and just return. And the reason why I do true is because, well, okay, it still satisfies the condition so far. And the way that I'm going to do it is if there's any condition which something fails, then it's false. But so far, like, okay, here to here, there's no problem. It doesn't break any rules, therefore we're good to go. We can keep going. If there is any false, like if this was 0, 0 right here, and then I would come and visit this one and then say, oh, no, doesn't count. And then we would just percolate that false all the way up. But so far, we come here and then we try to revisit this one. We say, oh, it's part of visited. So far, it doesn't break any rules. And then come back here and we say, oh, I tried to go left, and this is going to return true because we just hit it there. So we tried to go left. Left comes back as true, and then we're going to keep going until see if right, up, and down all are true. Okay, so, and then once we visit, or once we see that we haven't visited this node yet, then we just want to actually visit the node, or like put that into our set so that we don't do it again. Okay, so now what? So up, I want to return left and right and up and down. Okay. And same thing here, like if we hit a 1, okay, so far it's true, but we don't know that the entire thing is true, but we're just saying, so far no rules have been broken. Here's where the rules are broken. And if any of these are found to be false, then we have to percolate that up. Okay. So now, what's going to happen? This is result equals, and then here, and then if result, then we want to increment the number of islands, number of closed islands. One. Okay. I think it's fine. I think it's fine. Alright, so now I just return the number of closed islands. I think it should work. Let's see if this works. Well, it didn't, but we just have some weird thing here. Column. And did I do the same thing with rows? No. Okay. Let's see if it works. Come on, come on, come on. Nope. List outside. Oh, right, because we also wouldn't be checking if it's So I checked in this direction, right? If it goes in this direction, but I didn't check in this direction. Of course it's going to fail in that case, like here, like bam. And I also didn't check in that direction. Okay, so let's make sure that we do this. So if rows are greater than or equal to rows, or row is less than 0, then we want to return false. Same thing here. Or call is less than 0, then we return false. Okay, I hope. And boom goes the dynamite. There we go. All right. Okay. Awesome. Cool. So yeah, I'll just go back quickly over what we did. So we have these zeros and ones. 0 represents land, 1 represents water. 0 is you can check if it is a closed island by if all of the land masses or all of the entire landmass is surrounded by ones. So the way that we did this is we went and we iterated over each cell in this grid until we found a landmass. Once we found that landmass, we said, okay, I'm going to go and search up, down, left, and right. If each search that I do, if I find any instance in which there is a rule being broken, cut it off. It's not, well, continue the search, but we're going to be percolating that false all the way up. So we're going to come here and we're going to say, oh, this breaks the rule because we tried to index this right value. So we're going to come here, we're going to try to go left, and we're going to hit water. And then, so left is going to be true. Then we're going to come here, do traverse on column -1. Actually, that should be column +1. But anyways, I got those two mixed up. But anyways, we're going to come here, column +1, and this is going to return false. So false here on right, even though it's mixed up. So this is going to return false. And then we're still going to try to traverse up. This is also going to return false because it's going to say that rows is less than 0, right? Row is currently 0. And then I pass in row -1, which is -1. It's going to come here, return false. Say, okay, it's false. Then I'm going to come here and try to go down. Okay, great. Now I come here to down. So true, false, false, we're checking. So then we come here, we try to go up. Well, first we try to go column +1. So we come here, and this is false. So we say, okay. Then we try to go to right, try to go left, and we say, okay, well, this is true. It satisfies the condition. Then we try to go down. Awesome, cool. Well, then we try to go up. Then we say, oh, we already visited it. So this one's true. So up is going to be true. And then we try to go down, and then this one is also going to return. It's going to have false, true, true, true. So then we just percolate that up because this one right here, it says false. So this one is going to have false, and or down is going to be true. Then up is going to be true because right here is fine. Right is going to be false. And then that percolates up to this one, and now down is also false. So now we have like true, false, false, false. So there's 3 falses, and even 1 false is enough to justify cutting off the entire block. So this is how we traverse all of the nodes that are connected in this mass, but still have that but still are able to percolate the false all the way up. So anyways, thank you guys so much for watching this video. If you would like to subscribe, that would be awesome. My name is Timothy Lee Grant, and I hope you guys are having a wonderful, amazing, awesome Christmas. Happy birthday, Jesus, right? Go to church, all that stuff. Have a good time with your family, and enjoy Christmas. So thank you guys for watching this video. I will be back tomorrow. Does that mean Christmas, like December 25th, or does it means when I wake up? That's what I mean by tomorrow. When I was working grave shift, people would always be like, well, what do you mean tomorrow? My definition of tomorrow is after I wake up. That's tomorrow to me, because they'd be like, well, tomorrow is in 5 minutes, and I'm like, nah, no, tomorrow is after the 8-hour sleep. That's that's my tomorrow. So even if I go to sleep at, I forget what time I would normally go to sleep when I was working graves. I think it was like 7 a.m. or something like that. But anyways, so that was my tomorrow. After I wake up from the start sleeping at 7 and then wake up, that was a little while ago, so I forget the exact time frames. But when I wake up from that. Anyways, have a wonderful day, everyone. I hope you guys have an amazing Christmas, and I will see you guys, yeah, tomorrow.